Welcome to Volumes of Spheres. And it would make sense to start with the definition of a sphere. I'll remind you, the definition of a circle was the set of all points in a plane that are equidistant from a given point, which is the center. A sphere, we just don't say in a plane. A sphere is the set of all points that are equidistant from a given point, which we call the center. So if we're given this point, all of the points that are the same distance away from it form a sphere. Perhaps 4 centimeters away. 4 centimeters to the right, 4 centimeters to the left, 4 centimeters up, 4 centimeters down, 4 centimeters this way, 4 centimeters that way. 4 centimeters in every direction would form a sphere. So, some very quick vocabulary, just to be thorough. So just like on circles, the distance from the center of the sphere to the sphere is called the radius. And if we connect 2 points on a circle, on the sphere, and pass through the center, in other words, 2 collinear radii, that would be the diameter of the sphere, twice as long as the radius, just like on circles. Also, just like on circles, if we connect any 2 points on a sphere, we get a little segment called a chord. And that means a diameter is a chord, right? The diameter connects 2 points on the sphere. This happens to be the longest chord you can draw in the sphere. But if you take any 2 points on a sphere and connect them, that's called the chord. Same vocabulary as circles. Here's another familiar word. A line that intersects a sphere at exactly 1 point is said to be tangent to the sphere. Now, here's something a little new. If you slice through a sphere with a plane, so if we chop off the top of that sphere, for example, with a saw blade and just lopped off the top of the sphere, that cross section there would be a circle. So this is a circle that we could draw on the sphere all the way around. Here's another one. Here's another one. Whenever a plane intersects a sphere, it's either going to intersect it at exactly 1 point, if it's just sort of balanced on the sphere, or if it slices through the sphere, it's going to form a circle. And if that circle has the same center as the sphere, it's called the great circle. So this circle that I'm shading the interior of, so really this circle, has that point as the center, which is also the center of the sphere, so that's called a great circle of the sphere. This one would not be a great circle because the center of that circle up there is not the center of the sphere. If this were the globe of the Earth, that circle would represent the equator. And there's more than one great circle on a sphere. There are infinitely many. I could also draw a great circle like this. And if the center of that circle is the center of the sphere, that's another great circle. So, there's all the vocabulary we need. Now, throughout this chapter, I've been deriving the formulas for volumes of different solids for you. For the sphere, I'm actually going to link a video from an old video from the best teacher I ever had, Dr. James Tanton. And he was able to share a video that explains why the volume of a sphere is what it is. Generally, people say you need calculus to prove it, but he uses Archimedes' approach to derive the volume of a sphere with ideas from calculus, but something that can be followed without actually knowing calculus. So I'm going to put the link to that in the description to this video that you're watching. That being said, here is the formula for the volume of a sphere. 4/3 pi r cubed. 4/3 pi r cubed. Not pi r squared, pi r cubed. We're also going to be working with hemispheres, half of a sphere. And the amount of space taken up by a hemisphere is half of the space taken up by a sphere. So if we multiply that by half, we would get, let's see, half of 4/3 is 4/6, and that simplifies to 2/3. So the volume of a hemisphere is 2/3 pi r cubed, exactly half of the volume of a sphere. So those are the two formulas we'll be using. Again, check out the link below to see where that formula comes from for the volume of a sphere. Let's get into our problems. Although first, a calculator. To cube numbers on a calculator, if I want to do, 1.25 to the third power, sure, I could type in 1.25 times 1.25 times 1.25. But most calculators have an exponent button on it, and I know most of my students have this kind of calculator, so 1.25 to the third power, this button above the division sign is called a caret, and that means exponents, so there it is, to the power of 3. So this is going to cube that number. So if I do 2 to the power of 3, that's 8. If your calculator doesn't have that button, another button to look for that does the same thing is x to the y power. And you can play around with that and use that as your exponent button. Some calculators have a button that actually just says exp on it, and that means exponents. So 2 exponent 3 would get you the answer 8. So here's the first problem. What's the volume of a sphere to the nearest tenths if the diameter is 20? So this is really just checking to make sure you can put this into your calculator right. I did give you the formula. So the formula was 4/3 pi r cubed. And if the diameter is 20, of course the radius is 10. So 4/3 pi 10 cubed. And you could just type it in just like this and you'll get the answer 4,188.8 millimeters cubed. I chose just out of habit maybe to simplify first. So 10 to the third is 1,000, and 1,000 times 4/3 is 4,000 thirds. So I typed in 4,000 pi over 3, but either one gets you that answer. So that's a very straightforward example. The next few will be a little more interesting. So here's the next one. If the circumference of the sphere is 7 feet, what's the volume to the nearest tenths? Now I should clarify what we mean by circumference of a sphere. It's probably what you're guessing, but it does mean the circumference of the great circle. So if all the way around here is 7 feet, what's the volume of this sphere? I'll give you a moment to try that. Hit the pause button. All right, so circumference is 7. So we need to figure out what the radius is from that. And we can definitely do that. We have a circumference formula. Circumference of a circle is 2 pi r. So if 2 pi r is the circumference, but I'm told that my circumference is 7, then I can replace circumference with 7. 2 pi r is 7. So if I divide both sides by 2 pi, I solve for the radius, 7 over 2 pi. I want to pause here and make sure we're all clear that this does not equal 3.5 pi. That's a common mistake that I've seen my students make over the years. It does equal 3.5 over pi. So if you want to change your radius into 3.5 over pi, that's fine, but it's important to remember that that pi is in the denominator. So now that I know my radius, here is the volume. 4/3 pi r cubed. Now that's a tricky one to type into your calculator. And I'm really going to ask you to pause here if you haven't already and see if you can type that in correctly yourself and get that answer. And I'll show you what it should look like on my screen here. So 4/3 pi r cubed. So look at all those parentheses. I need one set of parentheses here and here around my fraction, 7/2 pi, the number that I want to be cubed. But notice I also have parentheses here and here to tell the calculator that the 2 and the pi are both as a group in the denominator. So for every open parenthesis, I need a corresponding closing parenthesis. If I have 2 open parentheses, I need 2 closing parentheses. The other way we could have done this would have been this. Let me see if I can delete and insert 3.5 over pi. And you'll see that's the same answer. So if we use the other version of the radius, we get the same answer. What's important is we're not rounding the radius off and using that rounded off radius in the formula. All right, how about this one? What's the volume of this hemisphere to the nearest tenths if the diameter is 13 inches? Well, if the diameter is 13 inches, the radius is 6.5 inches. But remember, the volume of a hemisphere is not 4/3, it's 2/3 pi r cubed. So 2/3 pi times 6.5 cubed is 575.2 inches cubed. I've got 2 left for you. Here's the 4th one. What is the volume of the sphere to the nearest tenths if the area of the great circle is 5 centimeters squared? So the only value we need to remember from this picture is that the area of the circle was 5. So here's my work. We know the formula for the area of a circle is pi r squared. So if pi r squared is the area, but I'm told the area of the circle is 5, then pi r squared is 5. So I divided both sides by pi. I took the square root of both sides to solve for the radius. That's the radius that goes into my formula. Again, notice I didn't round it off. So 4/3 pi times that radius cubed. There it is. Check yourself on your calculator. If your calculator puts a parenthesis here when you hit the square root button, you have to remember to close it before you say to the 3rd power. Answer 8.4 centimeters cubed. Last one. Look at that color. Getting fancy. So what I tried to find was something that looked like a tube of tennis balls, but I wanted it to be colorful. So suppose this was a tube of tennis balls. And I don't really know what the diameter of a tennis ball is. I just said 6 centimeters. But the question is, to the nearest tenths, what's the volume of this extra space inside this tennis ball container? What's the volume of that little extra space here and here and here and here? What's the volume of the extra space inside there between the tube and the tennis balls? Inside the cylinder, but outside the spheres. And the only measurement we're given is the diameter of each sphere is 6 centimeters. All right, well, seems like I'm going to want to know the height of this cylinder. And we can figure that out, because if the diameter is 6, it is 6 in every direction. This is 6, this is 6, this is 6. So if this is 6, and this is 6, and this is 6, then I guess we do know the height of the cylinder is going to be 18 centimeters. All right, so let's see the work. the volume of the extra space inside that cylinder is going to be whatever the volume of the cylinder is minus the 3 sphere volumes, 3 times the volume of a sphere. Take a look at the picture. I'll read it to you and just think about what I'm saying. It should make sense. The amount of space taken up by the cylinder minus the amount of space taken up by the spheres would leave me with that extra space that I'm looking for. So, I replaced my words with formulas. Volume of a cylinder, previous video, pi r squared h. Volume of a sphere is 4/3 pi r cubed, but remember we have 3 of them. And it works out nicely that 3 times 4/3 is just going to be 4, so that's why it just says 4 down here. So radius of the sphere is 3, the height of the cylinder we saw is 18. Radius of cylinder is 3, but also radius of sphere is 3. So 162 pi for the cylinder, 36 pi for the 3 spheres, 126 pi when you combine like terms, 395.8 centimeters cubed for the final answer. Hope that helped.